Hey guys, welcome to a really important class. In this one, we're going to talk about a lot about theory. In this case, we're talking about primitive and reference. This is extremely important because understanding how it works under the hood will give us a better sense of what we're doing and what we're going to do, or how the computer functions, and we could handle it better. All right. So far, we've talked about primitive types a lot, actually. These are built-in variables that Java gives us, or other languages could give us variations of the same thing. They're built-in variables. We have such like integers, characters, double, really anything that starts with a lowercase. And this is the important part. Because we still have double, but as a double. And we still have int, but as an integer. Okay? These are not primitive type because they start with a capital. We'll talk about these a bit in the future. They're more like a helper class for anything related to integers, or anything related to double, or anything related to characters, so forth, so on. But that's for a future video. For now, knowing that these primitive types exist, what is these reference types? And the thing is, right now we have these primitive types that are helping us do what we need to do, but eventually these are going to be limited to their creations. And to be honest, Java can't predict everything that we're going to create in the future, so they can't really predict every different type that we'll need or we'll use, especially since every application will vary based on what their needs are, right? So what we're allowed to do is actually create our own variables, and I'm going to create hundreds and thousands more, and this is basically the beginning of our OOP, okay? But before we could create these variables, we need to understand how it functions under the hood. And I'm going to do, again, a rough idea of everything. So there are some stuff that I'm going to be leaving out for now, and we'll come back to it later, or just have it, take it with a grain of salt. Come back to it later. Don't take it as the absolute truth. We'll come back and expand on those ideas. All right. So the first thing we need to understand is, how does the computer manage everything we do, the memory? We talked a bit about this. So there's this thing we call the stack. Sorry for my amazing drawings. Inside the stack, the computer will put in every variable that we have and the value that they are. So what I mean by this, let's go try it out. So when I create my main and I create a variable, let's say age equals 5, and then I create, let's create something else. Boolean happy equals to true. Can't spell, it's in the morning. What happens here is, on line 5 is the first statement that's running. On line 5, the processor will come on the stack. The compiler will come on the stack, or whatever you want to call it, and it will create a variable here, which is age. And it will store the value right in here inside the stack, 5. Same thing goes with happy. Any primitive types, really, they will always get created inside the stack. And the value of it will also be here. Okay? Now, what happens in the stack is any variables we create will be stored inside the stack. All variables created will be stored. I'm just going to write this down because it's important, in the stack. Now, this is possible until those variables are within the size limits of the stack's allowed size. And this is, let's say, this is really dependent on your language, but let's say we're going to, again, do it with a grain of salt. Let's say this size is dependent on the OS you utilize. So you might have heard of, we're at Windows 32-bit or at Windows 64-bit or at Linux 64, 128, etc. It always doubles. Well, this is kind of the size of the stacks for each variable, but also this is the size of our memory, which in this case we'll call our heap memory. So our heap memory is that memory that we install in our computer, and it gives us a X amount of size. And let's say every location inside this memory, every location inside this memory is mapped out. It's mapped out to an address, the same way as your city is. If I want you to go to my friend's house who lives at 156 Pine Avenue, well, you'll need to go to Pine Avenue. Well, I got to tell you actually the country, the province or the state, the street or the avenue, and the number of the house for you to be able to get there. And sometimes even give you the apartment number if it's an apartment. Well, the same thing happens inside the memory. The same way we have to say, go at 158 Pine Street inside, let's say, Montreal, Quebec, Canada. This is an address of where this person lives inside the world. He lives in Canada, Quebec, Montreal, Pine Street at 158. Well, if I wanted to do the same thing inside the memory, I will give an address to each one of these locations inside the memory. Well, you might have guessed it. These addresses are basically a binary number, a long binary number. So most of the times we actually use hex to make it shorter or more readable. But these are computer stuff. The point is, we have a binary location for each part of this address, starting with 000, going to the final location, right? Now, to reach this final location, this is what's important. We need a good amount of these digits, these binary numbers. And this is where your OS comes to play. When you have the 32-bit, well, it has 32 of these zeros and ones, 32 bits. When you got the 64, well, it has 64 of these, much bigger, right? So the final location over here, basically the size of your OS or the way it manages memory. So this 32 or 64 will determine how far of the memory can we go. Why do I tell you this? Well, when you insert a memory card, your memory card is going to be limited by this 32 or 64. Let's say you have a memory card that the final location is bigger than a 64-bit could reach. Let's say you have a 32-bit OS, but you have, let's say 16 gigs, actually 16 you could reach. Let's say you have 32 gigs of RAM, of memory. Well, the 32-bit could only reach here in address points. So the rest over here is not usable just because the OS cannot reach it. Okay, again, take it with a grain of salt. So it's important for us to understand that every location inside this heap memory is accessible by an address given to us. Okay, from 000 to the final being the size of whatever that was. Now, what's important for us is inside the stack. The stack is going to be the size of one of these. Well, whatever your OS is or whatever your compiler is. Sometimes it could be a bit different than to your OS. So each one of these locations are going to be the biggest size that we have, right? And we talked about our primitive types. One of our biggest ones being double, which is 8 bytes, etc., etc. And now we're getting bigger and bigger in sizes. But anyway, so inside inside our stack, we could only store a maximum size of a variable. But let me erase a little bit. But the problem comes down to, let's say we're at 64 bits. The problem comes down to these new variables that we're just talking about that we're going to eventually create that are not primitive. Who said that our size is going to be within the limits of what's been mentioned? Right? These new variables that we're going to create could be huge, could be quadruple the size of this 64 bits, let's say. Bigger than our double, bigger than 8 bytes, right? So how do we store something that's much bigger than our maximum allocated size? Well, we store them with something called a reference type. This stack will store an address. This isn't a keyword that's important. Let me actually go change color. This is the part you need to start understanding. So on the stack, when we create one of these variables, we're going to create an address. So we're going to, again, put the name like we did with the age and the happy. Let's say I'm going to put name. But the value on the stack is not going to be the value we created. Actually, we could test it out right now with one type that we know it's not primitive. We talked about this, which is string. Notice the capital letter at the beginning. Notice it's not orange either. String, let's say name, and I'm going to put my name here. Now, string, again, it's a special thing. We're going to come back to it many times. But what string is, it's a reference type, and we'll come back to it again. Let's not focus on this so much. But over here, you'll notice that the value, the initial value set is reza. But the problem is, this reza cannot fit on the stack. And it could have been even longer, just to make sure that you understand that this is, let's say, Reza, Artemis, Mona, Lisa, Polo, Kelisa. Who cares? Okay, you can see it's getting longer and longer and longer. It's not a set size. It's too big for a stack. Thus, it's not even a primitive. So what happens is we don't store the value here. We store the value somewhere on my heap memory. So I'll go find a location that's not being utilized by any other application, because here it could be our IDE, right? Here we could have our, I don't know, our browser, whatever browser you're utilizing. Here we have some other application. Here we have something else, etc., etc. So what's going on is we're going to find enough space to be able to fit this thing. So here I see that there's enough space that's opened up. I'm going to put the value there. Reza, Artemis, blah, blah, blah. This full value is right there. And inside my stack for the variable name, I'm not going to put this, but what I'm going to put is the address of where it is inside the heap memory. The address is here. The starting location is the leftmost part. Right? So I'm going to put an address in there. So I'm going to put a binary value, or in this case, again, I told you it's a hex. That makes it more readable. So we're going to put a hex value there, like 3F 5562, blah, 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 which represents, this is an address, which represents a location in the heap memory where is the value. Right? So this is an arrow that represents that location. Is that clear? Now, this is the beginning of this. This is important because anything we make bigger than primitive types, they have to belong in the heap. So whenever we create something, we're always going to create it in the stack. Not going to change. Every variable that you will create will always be on the stack. The difference is the value of it will not be on the stack. the value of that variable, the value of this variable name, is actually an address of where the value is located on the heap. Okay, and this is going to be really important, and we're going to start talking about this throughout the next bunch of videos, talking about objects, talking about arrays, talking about strings, so forth, so on. This is really important to grasp because addresses is how pretty much everything works or is going to work in our programming parts. Okay? So again, it's important to understand, let's reiterate one last time. All variables created on the stack, any variables that's not a primitive type, on the stack, the value is going to be the address, and they're going to be stored, the value is going to be stored, the real value is going to be stored on the heap. Okay? Did I forget anything I wanted to talk about? Well, this is good enough. Okay, one last thing we want to talk. Well, actually, let's write it down. So all variables. Let me pause it for a sec. All right, here. So all variables created on the stack, primitive or reference, doesn't matter. They always will go on the stack. The difference between them is that the primitive types will store the value on the stack, while the reference types, they will store the address on the stack. And obviously the address leads to somewhere in the heap. This is important. One last bit we're going to add onto this is that reference type has this magical thing we're going to come back to. When you initialize them, they could be initialized into something called null. Meaning currently they don't have an address. They're not on the memory. So you could have another variable here, let's say let's say home as an example, and I could set the value to null. So there's no address of the heap, there's nothing set. And this is something you could only do with reference type. So let's say again, string home equals null. Right? This is a interesting value, which is no value. Okay, we'll come back to this many times. Thanks guys, I'll see you in the next video.